Hello and welcome back. In the previous example of subnetting class B, we've seen /17. We also discussed the /16, which is the class for the default. And class B, you would have the network, the octets is structured like this: N, N, H, and H. And the N, it is all ones. So in the octet, you have 8. 1, 2, 3, 4, 5, 6, 7, 8, and then you have 1, 2, 3, 4, 5, 6, 7, 8, and then this H, 8 zeros, 0, 0, 0, 0, 0, 0, 0, that's 8, and then another 8 here, 0, 0, 0, 0, 0, 0, 0, 0. If you combine, it would be 8 here, 8 here, 0 here, 0 here, it would give you 16. But for our case, we have 18. That means we already have 8 there, 8 there. We need to borrow 2 slots from here, and the writing will be 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And then instead of 8 ones, we have 1, 1, and then the rest will be zeros. And then this one didn't change. It will be the same. That means you have 8 here, 2, and then 0. That's giving you /18. So for the 18, we know we wouldn't touch this one and this one. That's the network bits, but this will be the hosts. Now we come into the hosts and adding host and network together here. So we have 2 bits borrowed from here. That means our N is equal to 2 and our H is equal to, here if you combine 6 here and 8 here, that's 14. And the number over there, 1, 1 and 6 zeros, 1, 1, 6 zeros, that helps us to find the masks. So this binary number converted to decimal, it will be 128 and 64, that's 192. If we know that, we can calculate how many subnets and how many hosts per subnet. So the subnets is 2 to the power of n, and it gives you 2 to the power of 2, and you have a total of 4 subnets. Okay, 4 networks. For each network out of these 4, each one will have 2 to the power of h minus 2, which is 2 to the power of 14 minus 2, and that will be 16,000 something. Let me find out. 16,384. 16,384 minus 2. So you will have a total of 16,382 valid hosts. That means the IPs you can give to machines, routers, switches, PCs, laptops, phones, and all this. And we now have 4 subnets, and each one will have this number of IP addresses that are valid, plus the 2 that you use for network and broadcast. But what about the block size? The block size will be, if we take it as block size, and it will be 256, because in each octet you have only 256 minus the mask. And this mask calculation is right here. So if we have 256 minus 192, that means you have 64. So we have a block size of 64. That means if we start from 0, we go all the way to 63. And then the next one will start from 64 and will go all the way to 127. And the other one will go from 128 all the way to, if you add 64, that's going to be 191. And then if you add 192, if you add another 64, that will give you 256. But, 255. We're starting from 0, remember? So that's the block size. But this block size, and you have 4 networks. This is network 1. This is, let's call this subnet 1 so we don't confuse the other N. Subnet 1. Subnet 1. This is subnet 2. This is subnet 3. This is subnet 4. Okay? And this is the starting point. This is the end point. Starting point, end point. Starting point, end point. Starting point, end point. But now, this is not class C. Remember, in class B, we have 4 octets. X, 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 X. These 2 we were not touching. At the moment, we're subnetting here. And if we're subnetting here, the hosts were supposed to be from here all the way there, but we're adding network and subnets here. So these two octets are the ones you are dealing with. So we need to deal with X and X over here. This X is the network that will start from 0 all the way to, and we keep the X all the way to 63, and then we keep the X. The second number, which is 64, it will be the second octet. If this ended at 63, the other one should end at 64, but the other octet is still there for us. We continue all the way until it reaches the number we mentioned here, 127.x, whatever that X is. Then the next number to 127 is 128, so 128.x, whatever that number is, all the way to where it ends, which is 191.x, whatever that X is. We'll talk about those. Then you have the next one, which is starting from 192, which is 192.x, and it continues all the way to 255 with a .x. Now let's talk about the X. You know, in one octet, it has to be 0 all the way to 255. When that one completes in one octet, it will stop if it's just one octet. But we have an octet to increase. So if it started from 0 and this continued all the way 1, 2, 3, 4, 5, all the way to 255, the moment it becomes the next number, this 0 will change and will become 1, and then it will have 1.0. And this 0 will continue, and 255 then will change it to 2. And then again 0 all the way to 255, and the number will change to 3 until it reaches the end of the subnet, which is 63, which we identified over here. So 63 dot, and this number, when it's last to go to the second octet, it will be 63.255. That's the number that ends. If you go more than that, then this changes to 64, and that's the starting point of the second subnet. Then if we have 64.0 for the first number, the 0 will continue all the way to 255. Then the next number will change the 64 to 65.0, and it will continue all the way to 255, 65.255. The next number will be 66.250.0, and then it continues until it reaches 127. And then 127 will become 128 because this became 255. So it became 255. It made this one 128.0. If the 0 goes all the way to 255, then this becomes 129.0. That 0 will continue until it reaches 255. The 129 then becomes 130. With the 130 will continue until it reaches the end of the subnet, which is 191.255. The 255, if you add one more number, it will change this one from 191 to 192, and it becomes 192.x. So it goes all the way 192.255, 193.0, 193.255, 194, until it reaches 255.255. So that's a simple calculation. You're only dealing with 2 octets. If you happen to deal with class A, then you have 3 octets to deal with. This is 255. It will go until this one becomes 0, 1, 2, 3. Then again, that will fill this one. So this will remain like a stopwatch. Just play a stopwatch and see how the numbers change. And then that will become a simple 2-digit, simple 3-digit. Let me show you how to fill this information in a table. We had this example previously. /17, and we started from 0 all the way to, because only 2 subnets, all the way to 172. And when it fills 255, it changed it to 128 and starts from 0. The 128.1.2.3 until 255, it becomes 129, and then until it reaches 255. That we cannot pass because we're not touching and changing that digit. So the next number it can go to is 255. This will stay there. That's the end of the network because we were not touching this 2. Now it becomes this case. It is 172.16.0.0. If we take the first number, and if we forget about the first 2 octets, for example, we're not changing any of those, but this one, we said it will start from 0 all the way to 63. So we can fill that bit, 172.16.63. And if this goes from 0 to 1, 3, 4, 5, all the way to 255, Then when it passes 255, this digit will change to 1. It will continue until it reaches 63. And then 63, the last number is 255. If we add one more step, this becomes 64 and this starts from 0. So we have 172.16.64.0. And if we add a number, it becomes 64.1, 64.2, 64.3, all the way to 64.255. And then it becomes 65. It will continue until it reaches the end of the subnet, which we mentioned, which was 127 here. In here, 127. And then we fill the end of that, which is 172.16.127.255. And then the 127.255 is the end of the second octet, second subnet. If we go to a third, it will become 172.16. Then 127 changes to 128.0, and this 128 will continue until it reaches 191, and that 191 here becomes the end of the third subnet, 191.255. If it ended at 191.255, the starting point for this one will be first two octets the same. This one will become 192.0, and the 192, if you add 264, then we have 172.16.255, and the last number is 255. Now, if I ask you, what is the last valid host for subnet 3? Here's subnet 3, and the broadcast is not valid. The last one is going to be 172.16.191.254. If I ask you what's the last valid host for subnet 4, you know it's ending 255.255. So one step back, 172.16.255.254. One step back. The one before that will be 253. The one before that 252, and then you go all the way back. So the same goes for subnet 1. What's the first valid one we can use? 172.16.0.1. That's the first valid. And then the last valid, 172.16.63.254, just one step behind 255. And the first one for subnet 2 is going to be 172.16.64.1. And then the last one for this one will be 172.16.127.254. And the rest you can fill in between. And then you can create your spreadsheet, and then you can manage your IP addressing. And then you can create your address pools that way. These two examples are showing you only two subnets, 4 subnets. The more we go, /19 will give you more than that, 20. Try to practice and build a table like that. Go through these steps over here, where it shows you what's the default value for class B, 2 octets, which will show 88. And then the 2 octets will show you 00. That's /16. Then you build your /16. Here I put 16, sorry. I need to correct that. This is not 16. If you were watching at the beginning of the video, this should be 18. That means 8 here, 16, and then +2, 18. So you have 18 there. And that 18, we calculate the subnet mask from here. It gave us 192. So if you follow these steps, make sure you have this kind of style, or maybe you have a block and then you can map these things. Then you can create a table. Practice maybe 1 or 2, 3 times. Repeat as many times as you repeat until this becomes something you can do from your head. Thank you again for your time, and see you in another video.